Hi everyone, welcome to the .NET Roundabout. This is our third instalment, and I'm pleased to say that we're joined by Brad Abel and Ed Fretwell from Brad from ASOS and Ed from Moneybox. These guys are going to be giving us a couple of talks. Brad's going to go first, and he's going to talk about how ASOS is ensuring secure engineering in an increasingly complex environment, and then Ed's going to speak to us about intrinsic authentication at Moneybox with Azure Managed Identity. We are obviously on all the socials, Instagram and Twitter. You'll see the handles down the bottom there, but also you can comment on YouTube if you're watching this via YouTube, and I think we're also streaming on Facebook for one of the first times, so you can post your comments there as well. And at the end of both talks, whatever questions you've had that you want to post throughout the event, we'll catch up with Ed and Brad at the end, and we'll just put all your questions to them at the end. So yeah, I will let Brad crack on, and yeah, we'll get stuck into it. We'll give it another 30 seconds or so just to let people sort of catch up and get ready. Whilst we do that, I'll just let everyone know that obviously the Roundabouts, we put on a number of different events. This is obviously our .NET one, but we have 6 other meetups across Agile, Java, DevOps, testing, UX, and what's the other one? Agile. And in the day job, we also run a tech recruitment business called TRG. So if anyone would like to talk to us about speaking or appearing at one of our events, or you want more information about joining one of our events just as a guest, obviously just contact us via the social handles you see there, and of course, if anyone wants any sort of friendly advice on recruitment, writing a CV, interviewing, etc., just obviously give us a shout via the same media, and we'll help out wherever we can. So I think it's about good time to get started. So Brad, if you want to take over.
Cool. Yep. So once I start sharing the screen, I'm not going to be able to see the video anymore. So could somebody give me a cue to make sure you can see the slides all right?
All good.
Cool. All right. Cool. So I am Bradley Abel, and as was mentioned, I'm the principal security architect for ASOS. And just a bit of a background for us. So we're mainly an Azure house, but we're branching out into kind of multi-cloud, and kind of some of the challenges that we face on a day-to-day basis is obviously in an agile, high velocity environment. How do you ensure that we're delivering secure code, secure engineering, and how that's baked in essentially from the start. So to kind of to start off with, when you think about application security and where it was a number of years ago, it was pretty well, focused on the internal threat. The perimeter was effectively your boundary, and there was probably less of an emphasis on ensuring secure code and configuration. It was still important, but a lot of the effort was put around making sure your perimeter was kind of locked down. So obviously you'd still have code review, you'd still have some basic testing. Vulnerability scanning was still important, but there's a lot of emphasis put around network configuration and making sure your edge was secure. And if you move on to kind of the next phase, I would say it was around kind of the introduction of cloud and DevOps and starting to deliver code and infrastructure at scale. And I would say, initially that security was a little bit slow to embrace the cloud and to embrace, really rapid, high velocity deployments. So what you'd see is effectively an old way of doing things from an application security and security hardening perspective, and trying to shoehorn that in to a more agile, flexible, high velocity environment. And it didn't really, it came kind of, you cover off the basics, but you introduced, a lot of challenges and a lot of overhead. And I think this is where, this is kind of where a lot of organizations are still existent today. So, obviously you do as much as you can at the repository, checking for secrets, checking for vulnerable configurations, misconfigured code, and I think, kind of we're starting to get to the point to where we're getting a lot of the kind of baseline controls and a lot of the baseline kind of mitigations covered off, but we're still not quite embracing or kind of understanding the true complexity of the environment and the true complexity of, or the true risk of what the threats that we face are. So if we go on to the next one, the threats that a modern business faces in terms of overall security, engineering delivery, and application delivery, you've got threats all over the place, especially with the kind of the wider usage of open source and containerization, and third-party code. With some of the big breaches that we've seen, the kind of the attack surface is expanding for a business. From an open source perspective, you've got chain dependencies where one compromise within the chain compromises the entire dependency and application. Using open source images and using open source packages, there's a lot of kind of trust, or a lot of misplaced trust in the open source community. Not saying it's not bad or not good to leverage open source, but it does introduce risks that need to at least be acknowledged and be aware of. Same thing with JavaScript. When you load up most modern websites, the number of third-party calls and third-party hosted JavaScript and calls out to third party is quite significant. So, each one of those, dependent on how the script on your site is configured, is a potential attack vector. This is one of the ways that MageCart was able to be carried out. Exposure of APIs, and with the open nature of the cloud and API consumption, any of those APIs can either be abused from a business process perspective, or from a data leakage perspective. Cloud compute has a lot of benefits, but it requires a fair amount of effort and investment to make sure that that cloud compute is locked down. Third-party SDKs kind of ties in with the JavaScript. So, but from an application or from a web perspective, the gist of it is that as things become more modular and more broken down, the scale of the threats is kind of increasing. So it it requires us to have kind of greater visibility into all these things. And so what does that mean from a, from an engineering perspective? And it's something that we've seen is that, without adapting the way we do security to fit within their kind of ways of working and delivery cadence, that the responsibilities and demands on the engineering's time is increasing, and there's always going to be competing demands on their time to ensure that, one, features are being released and updated, that the code is performant or the application is performant, it's secure, it's scalable, it's reliable, etc. So, the demands on our engineers' time is significantly increasing, and as we introduce these new security toolings and security checks and security reviews, that demand is only increasing. As our landscape becomes more modular, it in a way becomes more complex. Engineers are expected to be experts in everything. So, especially in a microservice environment, everything down from the network to the application is essentially within the engineer's scope, which is a big expectation on any one small team or a person to be managing, and to expect them to be experts on it, I think is asking a lot of them. And with the explosion of containerization and that type of compute platform, there's increasing usage of some of these of kind of common open source tooling, and some of them are great and they provide a much needed function, but asking or expecting the engineer to understand the risks or identifying the risks and carrying out an assessment is potentially asking a bit much of them, and when they already have quite a stacked day job. Additionally, attackers are getting more sophisticated, as we've seen. With the scale of attacks, they're getting bigger. Attackers are leveraging all the same tools and technologies that we in the business are using, leveraging machine learning, leveraging containerization. They're getting more to grips and better with, understanding how cloud environments work and using that to their advantage to carry out attacks. So, a lot of these attackers are very clever, sophisticated engineers, and it takes more effort and more capabilities to ensure that we're protected against them. And the enterprise and technology supply chain is expanding, as we saw with some of the recent attacks against things like SolarWinds and some of the other big software vendors. It's just highlighting the fact that our environments, both cloud and traditional on-prem, and the application and infrastructure network is full of third-party vendors, and the complexity and the risks associated with that, I think, is still not quite understood from a most business perspective. And at the end of the day, a lot of times the responsibility of these tooling and ensuring the security of them falls to the engineers, and we need to help support them to ensure that they've got the right information and the right details to understand what is the actual risk and what do they go about, how do they go about mitigating it. So I'll talk a bit about, what ASOS is doing today to ensure secure code. So I mentioned some of the basics, from a code perspective. So, as part of our path to live process, ensuring that we are carrying out and conducting appropriate scanning. So that's, checking for things like, secrets, accidental leakage of secrets, accidental leakage of kind of confidential, information that could give an attacker an idea of our environment. Application scanning, dependency scanning, vulnerability scanning, pen testing, automated pen testing. So, we carry out a number of those common types of scans. Additionally, we're carrying out training for our engineers and our architects on how to identify and quantify the threats and risks with their specific design. So as part of every design, we try and carry out threat modeling, and as part of every pull request or change or introduction of code or anything like that, at least have in the back of your mind, am I introducing something that introduces a security risk, or am I changing something that reduces the effectiveness of a control, or in trying to get an idea of what might an attacker exploit to carry out an attack. Additionally, because we're heavy in the cloud, carrying out a lot of time, focusing a lot of time on automating secure configurations, so that way, it's not something that the engineer has to think about from ensuring effective security. It's just done kind of out of the box for them, and they can focus on delivering the application and delivering features. And then from a security design perspective, ensuring that everything is plug and play, and trying to adapt and update the whole end-to-end security design to make sure that it fits within kind of the modern design development process, and having that link into the automating security configuration. So effectively, an architect or an engineer can say, well, I want to deploy this application on this compute within this environment, this type of data, and all of that should be baked in to understand what is the threats that I have to worry about, what are the risks, if there's any regulatory requirements associated with it, and we should be able to carry that through all the way to production to help simplify and make their lives easier to ensure they're delivering secure code. And then just real quick, because that's, as I mentioned, that's all quite basic. And what we really want to do is essentially make security engineering a bit more sophisticated and a bit smarter, and take it really to the next level and reduce the complexity for our software engineers. So the first thing that we're looking at doing, or that we are doing now, is reducing the alert and issue overload. So at the moment, if you think about the number of scans that we're running, you've got dependency scans, you've got cloud configuration scans, you've got potentially image scans depending on the compute you're running, you've got potentially concerns around tagging or data classification. You've got all sorts of things that they have to juggle and prioritize. How do you compare SAST versus dependency versus, say, a cloud configuration? And at the end of the day, that gets quite a complex decision. So what we're trying to do is help them to prioritize their workload, and from a security perspective, and focus on what are the key risks that we need to be mitigating now based on the risk to the business, the risk to their application. The next one is ensuring consistent visibility for essentially from the commit to production. So the benefits of that is essentially what we can do is we can identify, let's say we've identified an issue within production, whether it's an incident or a vulnerability or something like that. We should be able to track that all the way back to the commit that introduced it. And then also, if it's an inner sourced application or package, we should be able to trace, well, that same situation could occur in X, Y, and Z in terms of these different platforms. So we should be able to detect that end-to-end traceability and have that wider picture. Code containerization brings large benefits. So a wider strategy for us is to make sure that our code is containerized, and that introduces some great benefits from a security perspective, because as part of our path to live, we can ensure that, or we can essentially have a separate process or a separate deployment where we might be able to, or we desire to sandbox it or run a series of tests against it to ensure that is there anything baked into the container or the image itself, or an internally running process that may not be discovered once it's in production. It just allows us to kind of run that code on any number of compute platforms or any number of environments and detect whether or not there's something malicious baked into it. Ongoing education is key, because from my perspective, the only way we can effectively prevent any sort of security attacks or any attacks is to ensure that we understand how to, what are the techniques that are being used in an everyday basis. So one of the things that we're doing is monthly sessions where we actually run through and get hands-on with pen testing toolings and red team toolings in just to get our skills up to speed, and potentially looking at expanding that out across our environment to essentially run an internal bug bounty program. But basically the best way to understand how to protect yourself is to understand how to attack yourself. And then the next thing that we're going to be focusing our attention on is leveraging more and more machine learning, because as you can imagine, with the kind of noise that an engineer and from an operational perspective, the number of alerts and telemetry that we ingest at the moment, there's no way that we can have eyes on everything. So we're really looking to leverage machine learning to help us to identify and profile our code on a continuous basis, so that way we can understand if something out of the ordinary or something unusual or risky has occurred, and effectively respond to it. Not necessarily block it, but to at least understand, is this a risk or is it a low risk, and what are the potential outcomes from that risk. That's the end of the slideshow.
Lovely. Thanks ever so much, Brad.
Yep.
That was great. We will look to bring in Ed now, and then we'll have questions for you both at the end of Ed's talk. So Ed, if you want to carry on.
Sure. Yeah, will do. Thanks, Brad. That's really interesting. Nice. Let me just get that going. Cool. All right. So yeah, I'm Ed Fretwell. I am head of Application Architecture at Moneybox. If you know what that job title means, do please let me know. But I guess I'm just part of the engineering leadership team here at Moneybox, helping us build the product and service. I'm going to talk a little bit about technology we use called Azure Managed Identity, which is kind of a security tool really to help us authenticate services access to resources based on what they are rather than what they know. So eliminating secrets and passwords where they're not needed. But before I do that, I guess a few bits of admin. So I'm sorry, I may need to go and answer the door at some point. Sorry if that happens. Yikes. Yeah, this room is a very weird shape. There's nothing exciting behind that small door. Don't worry. And the other thing is these slides, the first half are based on the Moneybox funding pitch deck. So they look really nice. after that, expect a significant drop in quality as I take over. Cool. All right. But anyway, on with the show. So I'm going to talk a little bit about the context, what we do at Moneybox, why this stuff is important, then go on to what managed identity is, why you might be interested in using it, the basics of how, and depending on how we do for time, a few examples in detail of how we're using it in different scenarios. Cool. So maybe you've heard of Moneybox, but we're a saving investment app and service. Our mission is to help everyone save and invest for their future. So giving information and services that help you make the most of your money. We make it super easy to get started. Our whole goal is around getting people involved and helping them achieve what they want. We're focused on bringing things together into our app. And as our product and service grows, we want it all to come together into this one usable app to help you manage your whole financial life. And the other key thing that matters to us is we're focused on not just providing a range of good financial products to our customers, but helping them with the outcomes they're trying to achieve. So are they saving for a house? Are they saving for retirement? Are they saving for, say, a wedding or a big holiday? All of those things. And that affects how we organize ourselves and what we care about and what we focus on, which affects our need for things like managed identity in the context of how we work. The other thing to say is we're growing rapidly. So again, this was from the pitch deck from about 18 months ago. We're now up to 650,000 active customers. We're looking after about £2 billion of their assets, be that cash or investments in funds and the stock market. And all of that adds up to us having an API that's receiving about 4 million requests a day. So it's a significant service at this point with lots of moving parts. Cool. So as well as my individual work, I run the Cloud Apps team. We're one of the 4 main engineering groups within Moneybox. So we have the 2 mobile app teams that focus on the on-device experience. We have our investment platform team that basically deal with everything that scales with the number of pounds of customers' money and the number of transactions we have. Our world is focused on everything that scales with the number of customers and products and features that we offer. And so a lot of our work is on making sure that a growing team, and this team has grown rapidly. We were about 4 people 18 months ago. We're now up to 23 and still growing. A lot of our work is focusing on the kind of problems that Brad was talking around there and making sure that everyone can work safely and quickly in parallel on lots of different things without having to be an expert on everything. I'm contractually obliged to say we're hiring as well. So all levels, great place to work. Come and join us. The jobs are all up on the careers site. But so in the context of all of that, engineering at Moneybox is very delivery focused. We work in multidisciplinary customer teams. So the pension team owns pensions from top to bottom, and they're empowered to do what's best for their work. Within that, we're all in on C#, .NET and Azure. We're not doing multi-cloud. We're focused on making the most of what Azure makes available to us. We don't use VMs. We don't do stuff with like Kubernetes and containers, things like that. It's all about delivery for us. And that means we're 100% platform as a service. And we manage all of that using Terraform infrastructure as code. And that management is a responsibility of the individual product development teams and every engineer, rather than a separate ops team or a separate DevOps team. In that world, we're also doing continuous delivery, release changes many times a day. Everyone's empowered to do that when they believe they're at sufficient quality. And so given all of that, given our growth, given the responsibility we've got, we're very keen on doing anything that increases the intrinsic safety in what we're doing, reduces the privileges we need to have as individuals, and reduces the complexity of what we have to do. So things that remove work from our day-to-day. And so in this context, when Microsoft adds services across the platform, because we use platform as a service, we're very well positioned to take advantage of them. And so managed identity was one of those things. It came in to mainstream about 18 months, 2 years ago, and we've been using it for most of that time. It's super simple, really. So apologies if you think I'm maybe dragging this out a bit much to go to 20 minutes, but hopefully there's enough detail here to keep it interesting. It really is conceptually simple. Step 1, you tell Azure to let a service have access to a resource. Step 2, Azure lets that service have access to a resource. The key bit here, though, is what's not happening. So we're not setting up usernames or passwords or shared secrets or anything like that. We don't have to add a user to the file storage and then create a password for it and then put that password in a secure vault and then provide a way to inject the password into the configuration of our web service. We don't have to do any of that. Azure manages all of that authorization in the background. And so what that means kind of behind the scenes a little bit is that a managed identity is a unique identity within Azure Active Directory for any Azure, mainly compute services, but any active service that you're using in Azure. And that identity is fully managed, which means that when you create your service in Azure, so for instance, this screenshot's got some app services where we host APIs and websites and things like that. When those are created, Azure also creates an identity within Azure Active Directory for that service. And again, when we remove it, the identity is removed. And that means we can then tell Azure to authenticate and authorize access to resources for those services in the same way you would for a user or a group of users. And that's done based on what they are. So allow the API to have access to the database rather than allow anyone who knows this password to have access to the database. And so, for example, here we're in the portal, you can, the Azure portal, you can specifically give a app service that you've set an identity up for access to specific parts of a key vault, for instance. Behind the scenes, all of this is running using the Azure Instance Metadata Service. Doesn't really matter, you're not exposed to it particularly in day-to-day, but it's part of the gears and magic that goes on behind the scenes to make sure that Microsoft can manage the infrastructure and the services that Microsoft provide know the context they're executing in. It's available to most, I think, all, maybe, compute services in Azure. And there's loads of different endpoints for different types of metadata on that well-known URL. That well-known IP address, essentially. So that's available locally on all VMs, all compute resources. For managed identity, there's an endpoint you call, which gets an OAuth token for a specific scope, and then you can add that token to your requests using client libraries to actually then authorize yourself and get access to that resource. So the example on the right is kind of the request you would form to get an OAuth token that you could then use to connect to Azure SQL. Again, the mechanics of how this works behind the scenes doesn't matter too much because there's some great client libraries for managing it for you. Cool. So why is that useful? Well, there's a few different aspects. So the first is you get a single consistent model using Azure Active Directory, regardless of the context in which you authenticated. So for people, there's all the usual things like two-factor authentication, restricting which countries they can authenticate from, restricting which IP addresses and so on, and with full auditability for people and their access. For services, you can use managed identity, as we've just discussed, and Azure will guarantee their identity. But once you've done that, we've then got unified framework for specifying the authorization for both people and things services. And we do that using Azure Active Directory groups and then allowing those groups certain privileges using Azure role-based access control, which I may refer to as RBAC. I don't know if that's a normal thing. It's what I've done in my head, but I don't think I've ever said it out loud. So sorry if that happens. And the impact of this is it's controllable. So there's no more secrets to manage. Connection strings do not include secrets, so we can use them as part of our infrastructure as code and configuration management without exposing secrets to team members or giving people excess privileges that they don't really need. And it's also auditable. And it also makes life simpler. There's no need for this kind of behavior anymore. So these screenshots are showing management of access keys for a storage account and a Cosmos DB. And in both cases, if you weren't using Azure Active Directory and Managed Identity, you'd have to be managing these keys yourselves. You'd have to be refreshing them periodically, getting them into the config of your app somehow, a whole load of noise that easy to go wrong and you don't really need to do. The other aspect, which is key for us, is risk reduction. So literally, you don't have access to the service credentials. You can't identify as a service. So there's no credentials to leak. It means I can't get hold of the production database password that the API uses and make some changes and pretend it wasn't me. It's harder to hide the tracks. And it also reduces the chances of error, connecting to the wrong thing, using credentials you shouldn't have, but you did for somehow. So there's a lot of risk benefits as well on that front. So in terms of how you use it, again, it's pretty simple. So step one is to give your services an identity. Managed identity isn't turned on by default. Otherwise, every time you created something in Azure, you'd get a load of noise in your AD directory and groups. So, but it's super easy to do. You can do it in the portal, on the command line. We do it using Terraform typically. It works for basically most compute services at this point. There's a full list on the Azure portal about what's supported. But we use it all the time for app services, function apps, the data factory, API management. And it's as simple in this case of clicking the identity link and then turning on managed identity. At that point, so in this case, it's an app service, but whatever service it is will show up in your Azure AD and you can start working with it. There's also an option to do this user assigned identity, but we've not found a use case for that. It's much easier to just let Azure manage it end to end. So once you've done that, the next step is to then go through the portal or, again, use the command line or infrastructure as code to actually grant permissions for services to any Active Directory object. So that can, at this point, that can now include our services with managed identity. It can include people. It can include groups of people and hybrid groups of people and services and other groups. So we've had some good benefits from using that to manage our hierarchy of groups and being clear about if you join this team, you get access to these dev resources by default, but you need this group to be in another one, so on and so forth. And it's simple to do really in the portal. We've had the UI varies by the type of resource, but we're using it live with Azure SQL, with Cosmos, and a bunch of other things. The example on the right here is for a storage blob. We've specifically given a Azure AD group and the single app service contributor rights to it, so they can access the documents in that blob storage. And the bottom example is the same one we saw before around key vaults. So it really is that simple at that point. Okay. All right, slides a little bit out of order. So the next step then is to configure your clients to actually then use the managed identity. So in your client code, so for instance, a web API or a function app, you have to pull in the managed identity libraries. So there are two client libraries you can get from NuGet. We mainly use the app authentication library because that was the one that was around when we started out on this journey. But that's older, it's .NET only, and it's kind of managed identity focused and a little bit inconsistent. The newer version is the Azure Identity Library. That's kind of part of a wider unification of authentication and authorization across Azure. It works across languages and it's much more consistent in terms of how you use it for different services. But both work, and they both work in the same way. You ask it to get you a token for a scope, and you give that token to the Azure client you want to use. So the examples here, we've got in-app authentication, you use this as your service token provider to get a token, and then it also provides then a callback interface that the Key Vault SDK can use to grant access. And here we would do this, follow this pattern to give one of our web apps, say, access to Key Vault. The Azure identity model is basically doing the same thing, but looks a little different. You don't need to understand that there's a callback going on or anything like that. You just create the client and give it this default Azure credential object, which is the main mechanism that Azure Identity provides, and that handles all of the getting of a token from the metadata service, adding it in, all of those bits. Both of them take care of all the messy work for you. So they do token pooling, caching, expiry, refresh, all of those bits. And it really is simple. It just kind of works on that front, particularly now the library support in the clients have matured. So it's been going well for us. The other thing that I would say, we use Azure SQL a lot, and granting access to that is a little bit different. Because Azure SQL relies on the fundamental SQL Server user and credential and data access model, you don't provision SQL Server users through the Azure CLI. You do that directly within the database. So using these things called database contained users. And in order to do that, you must be a privileged DBO-ish level SQL user and run a create user command. However, when you do that, you can use this create user from external provider syntax to create a contained database user, which maps back to an Azure Active Directory object. And that way we can hook up our database users to our managed identities. In practice, we use a series of Azure AD groups for that, which are created when we create the database. And that means we only need to run this script once when we create the database. And we can then manage the group membership via Terraform as normal, rather than having to add each AD user individually. And that's working well for us in production, and it's been going quite a while. It also kind of radically simplifies the number of ways in which people can get access to our database. So we've got much more auditability. Cool. So when I said it was easy, I mean, I'm not totally sure how legible it's going to be. This is the code I wrote when we were trying it out, and it worked. Even though it's a very naive implementation, it worked completely fine at the scale we're at for quite a while. It's literally grabbing a token from the token provider, checking that we're not running locally, and then attaching that access token to a SQL connection, which is all you need to do to then present your authentication token from managed identity instead of a username and password when connecting to a database or an Azure database. And it means the connection string literally just contains a server name and a database name. This approach, however, did rely on the engineer to remember to call it when they're connecting, though. So as soon as it got out of my hands and into one of the more capable members of the team, we can switch to actually add the tokens using the entity framework connection lifecycle. So this code is just intercepting the on connection opening event or on connecting event, checking if it's a database that we do want to use managed identity for, and assigning the token. So that it's now completely seamless for everyone. You don't need to worry about it. You just can get on with your development life without needing to worry about protecting secrets and tokens in that way. The last little nice aspect of all of this is you can authenticate locally without changing your code or your configuration. So both of the token client libraries actually will try a series of different mechanisms for getting credentials for you to make your connection. This is particularly useful if you're developing locally, but part of your development environment needs to connect to, say, a development instance of blob storage or a key vault or whatever. So when you try and call one of those default Azure credentials or the token provider methods, they'll initially try and use managed identity or environment variables if they're in an Azure environment. But if they're not, they'll then fall back to all of these interactive sources. So you can then authenticate as yourself without changing any of your code directly from Visual Studio or whatever IDE you're using, which is a nice touch. And lastly, authorization is now part of our infrastructure as code. So it's all defined in Terraform. Service X has access to Y. It's managed in Git, reviewed via PR, applied via CD pipeline. No one has to worry about secrets. It's all modularized and standard. So again, as Brad was saying, we've reduced the amount an individual engineer needs to know to do their work safely, which is a great win for us, and it's made us able to kind of deal with the increasing complexity of our environment without running the risk of exposing stuff inadvertently. So I guess in summary, Managed Identity lets you authenticate your apps because of what they are. It provides a unified auditable authorization system for people and services, reduces the attack surface, simple to use, and we really like it. And we've had a lot of success for it over the last 18 months or so, and we're still hiring. Cool. So hopefully that was useful. That's it from me. Thanks, everyone. Oh, Rob, are you talking? I think you're muted.
Classic. Yeah, I was just saying thanks to both of you for your talks. They were really, really good. And I do have questions for both of you. So I'll start with Brad, if I may. If you were starting an e-commerce company from scratch, how would you approach security then, and how different would it be from what you do at the moment?
So I don't think, if I was starting it from scratch, I don't think we would do things massively different, because I think we're finally to a place where we are, leveraging kind of, all of the capabilities and adapted to the way our engineers run. But we've kind of had to go on a bit of a journey to get there, because as I mentioned at the start of the slides, that I think security was a little bit slow to adapt and embrace the cloud. So I think in terms of now, I would probably keep going on the path. I would have started it much, much earlier in terms of getting a handle on it. But I think one of the key things that is important when kind of starting out any sort of a new initiative or anything like that is understanding, say, your data or your risks, and tailoring the security around your compute and your environment, because essentially the data will dictate what level of control or level of effort you need to go to from a security perspective. Additionally, I would, recommend automating the basics as much as you can. So Ed mentioned they leverage Terraform to do a lot of their kind of out-of-the-box stuff, which we use a combination of Terraform and ARM, but I would say that we started much later than when we should have done. So we've kind of had to, it's been not a fight, but it's been more effort than I think would have been, say, if we just done that from the start. And the last bit I would say is rely on the native platform. So assuming you're running in a cloud environment, we went through a bit of a journey where we've effectively re-platformed and ripped out and replaced a lot of our old legacy security tech and actually moved more towards leveraging the native cloud capabilities, because compared to a couple of years ago, what's provided out of the box from the big three cloud providers is night and day. They've come a long way from where they were a couple of years ago. And as I mentioned, managed identities, is absolutely amazing in terms of managing reducing the need for managing secrets and such, because that's one of the big challenges that we have today. So I probably, where we are, we've got quite a good handle on it, but I would just get those basics right first, and then once you understand the data, then you could start doing the more advanced stuff. And there's loads of great open source tooling out there in terms of the security. So the kind of industry has moved on quite a bit. So there's a lot you can do with just out of the box capabilities.
Sure, absolutely, yeah, definitely. Ed, I don't know if you have anything to add to that or different take on it.
No, I'd probably echo that. I mean, our focus has always been use the stuff the platform provides if you can, because they'll have done a better job of it than you. And
yeah,
and just and I guess as Brad mentioned in the talk, just making sure you're aware of when you're opening something up, when you're taking a risk, what you're doing there, and being conscious of that. But yeah, I agree with what you said.
Cool. I guess also Brad. I suppose both of you could answer, but in terms of the obviously, it seems like we're certainly hearing more and more about threat levels and that sort of stuff. Do you have any particular opinions as to what's driving that?
Money. I mean, so we deal with a lot of being an e-commerce site. We deal a lot with a lot of the same attacks. So there's obviously kind of the data protection stuff, but like with the Xbox and some of the PS5 launches and things like that, we deal a lot with reseller bots, and there's big money in it. So, and I think it's starting to get more and more visible, some of the capabilities, and more into the hands of everyday people. So the capabilities to carry out an attack or resell or any of that stuff is becoming quite a sophisticated industry, quite easy to use. And so, there's going to be a spike of activity because there's money in it.
Yeah. What do you reckon, Ed?
Yeah, I mean, basically saying for us, I think the tooling for a lot of the more, may as well give it a try attacks is much more prevalent. So we see quite a lot of people attempting password credential stuffing attacks of leaked passwords and things like that. That, even if they succeed and find a company that's not defending against that and get access to an account, it's probably worth their while just leaving the computer running with a script they got off the internet and seeing what happens. So I think it's just, as you say, getting easier. And then for us as a business, I guess profiles growing, so people are more aware of us as a target.
Yeah, of course. And obviously with the kind of going back to what you were talking about earlier, Brad, there's inevitably both like engineers and obviously with lots of tech startups and what have you, people like to use open source tech, and there's obviously like lots of engineers like to be able to sort of contribute to that and share what they're doing in open source on open source stuff. So how much do you think that might be, or is either being curtailed or might be curtailed because of these sort of things? I mean, I guess how many companies are likely to be a little bit nervous now about sort of sharing what they do?
So I'm a big fan of open source. We use open source quite regularly, and I think community-driven stuff is incredibly useful and important to continue to build on. I think there's probably going to be a bigger scrutiny on ensuring that the open source capabilities we are leveraging goes through a similar level of due diligence as we would say a third-party supplier, because, and at the end of the day, a third-party supplier, you get less visibility than you do an open source code commit, because you can see every single commit, you can see whether they're verified or not, what was changed, etc. But who sits and necessarily goes through all of that and actually understands it? There could be all sorts of things that have committed in that, and how do you identify it? So I don't know if it's necessarily going to be curtailed, because I think it's too important to businesses to continue expanding and leveraging and innovating, to stop using open source. But I think there's probably going to be more focus on the risks, and how do we essentially quantify the risk associated with specific packages or specific open source repos in following a similar kind of process as you would do with any other company.
Sure, of course. Anything to add there, Ed?
Yeah, no, I think it's largely just a case of being aware of what you're getting into and where you're, I guess, thinking about it from a threat point of view, like where does this bit of code I'm adopting sit in my overall picture? What harm could it do? Okay, well, I'll apply a lot of diligence to that, or I won't. This one is, correcting date formats over here. I'll probably leave that one less scrutiny than some of the others, but just applying sensible risk profiles. I mean, and I think it is inevitable. All we're going to do is get better at managing the risk we're taking on and having better, smarter tools for scanning stuff automatically. I used to work as a CTO at a much bigger corporate company working with public sector stuff, and so very low risk appetite, and they just couldn't have done business without open source stuff. So if it's in that world, I think it'll be, it's here to stay.
Yeah, of course. Yeah, sounds good. Also, so moving on to your talk, Ed, and some of the questions we've got from that. I guess, what were you doing to? I know you obviously started using managed identity 18 months ago, but how did it look sort of before that sort of, and what would your alternatives be? I guess if you, for whatever reason, weren't using it, what maybe if you weren't sort of massively into Azure, for example.
Okay, so right at the start of our journey, it was someone created a database user for the web app to use, and put that the password for that into a password manager, and then injected that into our config files using the deployment service when we deploy it, and probably used that password themselves a few times to check the data looked okay and all of those things. And it's, if you're careful, you're a small team, it's not a bad thing to do. But when you're a bigger company, there's too much that can go wrong there. If we weren't going all in on the Azure approach, what you typically then start to do is move into the kind of infrastructure as code world, like we're doing with Terraform, but also use a secrets manager alongside that to help kind of keep your secrets centrally managed and merge them in with the deployments as you're hitting whatever particular cloud or containerized environment it's doing. And having I'm struggling to remember the name of the products now, but there's a companion one for Terraform that manages secrets. I think it's Vault, maybe, that you can do that as well. So you still have to manage the secrets, but those systems provide kind of APIs for requesting a new secret that no one ever knows, and using it once to create accounts and things like that. So there's modern ways of doing it that give a similar level of safety, but it's just more moving parts.
Yeah, for sure. And have either of you, I guess, or the businesses ever actually calculated how much time and money tools like managed identity are actually saving you?
Not really. I guess we count it in terms of how much grief we get from the business about when features are going to be delivered, rather than necessarily doing time and motion studies and things like that. And to be honest as well, a lot of this is the cost of doing nothing is too high. The cost of not doing it and the potential risk in not doing those things, rather than necessarily, oh yes, we've achieved 50% developer productivity increase or whatever.
Yeah, I think from our perspective, because we're still in a bit of a mixed state where we have both, where we use managed identity is just night and day in terms of ease of use and speed of use. So I know there's benefits from a security perspective, but yeah, in terms of the overall process and getting an identity assigned and getting correct permissions is much preferred in terms of overall speed and efficiency. But I've never calculated, but I can imagine it's decent.
Yeah, sure. We've got a question from David on YouTube, and this is for Ed. How do these packages, Azure authentication and Azure identity, relate to things like MSAL, e.g. for app WR back, React frontend, .NET Core, API backend?
So for the app authentication thing, I'm pretty sure it doesn't. I think this is just for authenticating as a service within an AD, rather than kind of tying back to the front end clients and who's doing that. And I might be wrong about that, because we're mobile native, so we've not even tried to join those together. We have a separate authentication authorization mechanism for our users within the world of our application. For the Azure identity stuff, although I've just been talking about it in the context of managed identity, that's part of a wider rework of all of the Azure SDKs, which may well include some other stuff around the role-based access control that hooks up to other libraries. But I don't know, to be honest. We don't use it.
Sure. Do you, in terms of like both of you, I guess, what would you sort of want from Azure in terms of sort of looking ahead? What could Microsoft be doing to make life a bit easier again for you guys?
Yeah, it's an interesting one. I mean, we use a lot of, as much as possible, to be honest, of their tooling, and there are areas where you still have to drop back down into, okay, I'm going to configure my own networking or my own VM or my own stuff here to get things done, and then we sort of have to then crowbar that back into our pipelines that were working quite naturally. So you sort of, because we're PaaS focused, as long as we're using platform as a service stuff, everything's lovely. As soon as we have a toe hang, teeter over the edge into the world of infrastructure as a service, the joins start to show pretty quickly. So I guess just increasing that surface footprint of what the platform as a service tools can do for us is the most helpful.
Yeah, I would echo that to an extent. There's a lot of when you're running IaaS, there's a lot of areas where things can go wrong, and it would be easier if it was just on by the start, rather than me having to define a policy or defining ARM or something like that. So there's that aspect of it. And I know they're making some strides into it, but at the moment, it's all very centered on. So we're split between Azure DevOps and GitHub, and a lot of the capabilities is centered on obviously Azure, because that's what it is. But bleeding that integration, say, into the pipeline and into the repo, because they're all integrated in the same, from an identity perspective, would be beneficial, because then you get earlier sight and you can fix a lot of these issues. So that's something. So we work with them quite regularly, and that's that would be a big thing for us, is making sure that we get as early as possible.
Sure, of course. And I guess because it always seems like it's a fundamental part of every meetup talk, I guess, the fact that everyone's always hiring and stuff. And I guess it would be good to get your personal takes on what you find when you're hiring people for your teams. What do you see as sort of the if you were someone listening to this talk and you were thinking about applying to ASOS, Moneybox, what have you, what sort of advice would you be giving people who want to maybe join the team, and as to what they should be looking into, what they should be, what your expectations are, I guess, or the things that you kind of see, where the struggles you find, sort of trying to get people, where could there be I guess a gap in the market, I suppose, almost.
I guess, well, from our side, there's an aspect where it's just basic. Hey, you need to have a level of familiarity with the tech we're using, and sort of be willing to learn and grow about on that side of things. But really, what we're looking for, because we're so delivery focused and kind of we want to try and use as much as possible of each individual's brain in service of the customer. We're really focused more on the kind of behaviors and values side. So kind of working with colleagues, non-technical colleagues, to understand the problem and being a partner in the solution, as opposed to just being handed some requirements. Being able to sort of problem solve and at sort of junior level, or perhaps come up with technical designs and have a rationale for it at the more senior level, and kind of reflect on that in hindsight, and also kind of sort of being structured about how you work. So planning and breaking things down, being able to talk about what you're doing to other people, those kind of wider things that enable you to then be kind of have freedom in what you're doing day to day, because you're communicating it well and working well with your colleagues, is really what we're looking for. Because then it means we've got a team where everyone's doing something meaningful and substantial that is theirs, rather than being drip fed little bits of code to change here and there.
For sure.
Yeah, I would agree. I think the collaboration is key, and making sure that because we kind of blend between security operations and the engineering and the developers, ensuring that you break out of that kind of silo that sometimes exists within security operations. And especially where a lot of modern businesses go, that's more and more key and critical going forward, to ensure that you understand the risks, you understand the challenges, you understand the perspective from the engineer in order to work together for a solution, rather kind of than the traditional way of handling security. And I would also encourage folks that are either interested in engineering or interested in, say, security at ASOS, to get an understanding and awareness of the cloud, kind of modern computes, things of that sort, and get to grips with how you engineer, or how a modern SDLC and write code and build applications. And then from an engineer that's interested in security, I would say, there's plenty of tools out there that are, free to test your hand at pen testing or red teaming, and really start to understand the approaches and methodologies that, these attackers use on a regular basis. Because, a lot of them aren't rocket science, but they're going after low-hanging fruit, and those are the easiest things to go after. So understand what they're doing and why, and then build on that.
For sure. Great. Well, I think that's questions exhausted. So just want to thank you guys for giving up your time for us tonight. And obviously, the other thing I was going to ask, actually, Ed, some of your example slides. I don't think the code quite came up on the video. If you wouldn't mind, both of you, in fact, I could ask this too. If you would be okay to sort of share your slides afterwards, then we can make them available just so people can kind of see the detail in some of them. That'd be great.
Of course, happy to.
Perfect, thank you. But yeah, so we are obviously going to be doing another .NET Roundabout next month. I just need to confirm the date with our various speakers and what have you. But I appreciate all your time tonight, guys, and obviously, for all of those people that are watching at home, thanks for joining us, and we look forward to seeing you again for the .NET Roundabout soon. Anyone who's interested in our Agile Roundabout, we've got a talk tomorrow night. I think that starts at 6. But I'll leave it there for this evening, and see you all again soon. Thanks, guys.
Thanks.
Thanks. Bye.
Bye.
Bye-bye.